Hello, I had some requests for some help for homework 13.3, 13.4, and 13.5. So I decided to do some of the problems for you and explain them out. Okay, sorry about the shake. I'll try and keep the shake of this table to a minimum. Okay, so the first problem on the homework, assume that two fair-sided dice are rolled. First compute P of F, which is the total is 8. And then the probability of F given E. And E is the event that the total shows on the dice, that an even total shows on the dice. Explain why one would expect the probability of F to change as it did when we added the condition that E had occurred. Okay, so first let's compute the probability that the total on the dice is an 8. So with that, the easiest way to do that would to construct the sample space. Okay, and the sample space is all the possibilities that can occur. Okay, so the sample space, and we'll start with the first die. We could roll a 1 and a 1. For the second die, we could roll a 1 and a 2. We could roll a 1 and a 3. We could roll a 1, 4, 1, 5, a 1, then a 6. We could roll a 2, 1, a 2, 2, 2, 3, 2, 4, 2, 5, 2, 6. We could roll 3, 1, 3, 2, 3, 3, 3, 4, 3, 5, 3, 6, 4, 1, 4, 2, 4, 3, 4, 4, 4, 5, 4, 6. Okay, again, what I'm doing here is this is the first die I roll. This is the number I get. This is the second die I roll. This is the number I get. And we're just creating all the total different possibilities, and that makes up the sample space. So I was a little more formal here, but I'm just trying to get it written quickly. Okay, so then 5, 1, 5, 2, 5, 3, 5, 4, 5, 5, 5, 6, 6, 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, 6. Okay, so those are all the possibilities. And the event that we're looking for is if we roll the total on the die is an 8. Okay, so let's go through and we'll highlight the totals that would give us 8. So 2 plus 6 is 8. 3 plus 5 is 8. 4 plus 4 is 8. 5 plus 3 is 8. And 6 plus 2 is 8. Okay, so now the probability of F, so the total number of outcomes in which we roll an 8, 1, 2, 3, 4, 5, out of the total number of outcomes. So we could count these all up, but the quick way to do is to use one of your counting rules. Since we have 6 sides of a die for one die, there's 6 sides on a die for the second die. There's going to be 36. And you could count 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, so you can see there'll be 36. So the probability is 5 over 36. If we want the decimal answer, just in your calculator, 5 divided by 36. And I would round it to 3 decimal places, so 0.139. Okay, now we need the probability that we roll an 8 given that we know the die was even, or the sum was even. Okay, so there's a formula for this. Okay, you could use your formulas Okay, you don't have to memorize any of these formulas. You can use the book, remember, when you take your quizzes and your tests. But the formula is the probability of E and F over the probability of E. So we have our sample space, which makes this easy. Okay, so we need the probability of E. Okay, and the probability of E is that an even total shows. So we can look through. I wish I had another color highlighter on me. I do somewhere, but I'm going to circle all the evens. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So it makes sense that half of them should be even, correct? Okay, half of them will be odd, half the sums will be even. So the probability that the sum is even, okay, there's 18 out of 36. Okay, and now we need the probability that we get an even and an 8. Okay, so that means both have to happen. The sum has to be 8. It also has to be even. Well, if we look, this is 8 and even, 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 this is 8 and even. So there's 1, 2, 3, 4, 5 out of 36. Okay, so now we just simplify this. 5 out of 18. And we get 0.278 as the probability. Why does the probability of F change? Well, I'm kind of missing some of that question there. Why does the probability of F change given that we specified that we know that the total is even? Well, because now, okay, originally it could have been even or odd, but if we know it had to be even, well, 8's an even number, kind of lowers our chances, and that's why. So the event E doubles the number of possible outcomes, increasing the probability. The event E doubles the number of possible outcomes, decreasing the probability. Well, we know it increased the probability. The event E halves the number of possible outcomes, increasing the probability. So that would be D. Okay. Actually, I shouldn't have given you that one because I should let you figure that one out on your own. Okay, so 2. Okay, assume that 2 fair die are rolled. That's actually pretty similar. So I'll skip that one. 3. We are drawing a single card from a standard 52 card deck. Find the following probability. The probability we have a heart given red. So we'll do this one because it's a little bit different here. Okay, so we want the probability that we select a heart given we know the card is red. Okay, again, the formula, probability the card is red and a heart divided by the probability that the card is red. Okay, so again, if you're not sure what makes up a 52 card deck, just look it up. Okay, they'll have that information in the textbook. Okay, or you can, look that up, grab a deck of cards, sort through it that way. Okay, but there's 52 cards in a deck. There's 4 suits, okay? It's broken up evenly, so if you do 52 divided by 4, there's 13 cards in each suit. 2 of the suits are red, 2 of the suits are black. So that means 1/2 of all the cards are red. And that means 1/4 of all the cards are hearts. So here we want the probability that we select a red card. Well, that would be 1 out of 2. It would simplify to 1 out of 2 because there would be 26 out of 52 cards are red. Okay, now we want the probability that the card is red and is also a heart. Well, how many hearts are there? There's 13 hearts out of 52. How many of those hearts are red? All of them. So the probability that the card is red and a heart would be 13 out of 52, which simplifies to 1/4. Okay, so again, we're just working. You work the individual probability in the numerator and the denominator, and then you can plug it in your calculator. 0.25, because that's 1/4, divided by 0.5, and we get 0.5 is the probability, which should make sense, because, okay, given we know we picked a red card, what's the probability it's a heart? Well, half of those red cards are hearts, half of those red cards are diamonds. So you have a 0.5 or 1/2 chance of selecting a heart, knowing that it's a red card. Okay. 4. We are drawing a single card from a standard deck. That one's very similar to 3, so we'll skip that one. 5. You are to randomly pick one disc from a bag that contains the discs shown below. Find the I don't know what color these are, so I'm gonna have to skip them. I can look those up later and just fill out this PDF and send it up as a PDF, but I didn't have a color printer here. Okay, so 8, assume that 2 cards are drawn from a standard 52 card deck. Find the following probabilities. A, assume the cards are drawn without replacement. Okay, remember, it's very important to know if it's with or without replacement. If it's without replacement, that means when you select a card, you're holding on to it. You're not putting it back into the deck. Those would be dependent events. With replacement, you select a card, record it, you put it back in. That's called independent. It's very important to know if it's independent or dependent. Independent's easier to work with. Okay, so find the probability of drawing 2 face cards. Okay, so the face cards, Jack, Queen, and King. Okay, so this is number 8. Okay, so there's 4 Jacks, 4 Queens, and 4 Kings in the deck. So that means the probability of selecting a face card is 4 plus 4 plus 4. That's 12 out of 52. Okay, which simplifies to 3 over 13. Okay. We want the probability of drawing 2 face cards without replacement. So we want the probability that our first selection is a face card and that the second selection is a face card. And remember, we're doing this without replacement. So when we select our first face card, we have 12 face cards, and I'm not going to use the simplified version. It's easier not to, okay, for this problem. We have 12 face cards and 52 cards to choose from. So the probability that we select a face card is 12 out of 52. It's an AND probability. You can look up your formulas. You would multiply. Now we need to select our second face card. What's the probability that we select one face card and then another, but it's without replacement. So we make the assumption we've already selected one face card and we're not putting it back in the deck. So there's only 11 face cards in the deck left to choose from. We've selected a card. We haven't put it back in the deck. So now there's only 51 cards left in the deck. So we just do 12 over 52 times 11 over 51 is 11 over 221. You want to convert to a decimal. That's about 0.050. This 7 bumps the 9 up to a 10, but we can't put a 10, so we bump the 4 up, 4 to a 5, and we keep that 0 at the end to show that this was rounded to 3 decimal places and not just 2. Okay. Okay, so that was A. And for B, it has the probability of drawing 2 face cards with replacement. Okay, again, remember with replacement it's easier because that means the 2 events are independent. So the probability that we get a face card and a face card. Doesn't really matter if I specify first and second because the probability of each is going to be the same because whatever we select first, it doesn't matter. We're putting it back in the deck, so it's not changing the probability of our second selection. So the first choice, there's 12 face cards out of 52. Okay, again, it doesn't matter what we selected. We're putting it back in the deck, so there's still 12 face cards out of 52. So we could simplify it to 12 over 52 quantity squared, however you want to type it up. 12 over 52 squared is 9 over 169, which rounds to 0.053. Okay. So it should make sense that we have a little bit better odds selecting 2 face cards if we replace the one we've already selected, but it's not like it ups it very much. Okay. Let's see, I'll do and this is just your homework assignment. I printed it out so that I could do some of the problems with you. 9 is similar, so I'll skip that one. A container contains 30 green tokens, 10 blue tokens, and 4 red tokens. 2 tokens are randomly selected without replacement. Compute the probability F given E. E, you select a non-blue token first. F, the second token is non-blue. Okay, sounds pretty wordy. Well, let's get down to business. Okay, so a container contains 30 green tokens. So let me write 30 green, 10 blue, and 4 red. 2 tokens are randomly selected without replacement. Compute the probability of F given E. So this is the final probability we want to compute, which is the probability of E and F over the probability of E. Okay, that's the formula there. And E is, you select non-blue first, and we will need that probability. F, the second token is non-blue. The second is non-blue. Okay. Okay, so first we really need to write down the information that we're working with. And this is the final probability we need. But in order to find this, I like working on the plain probability of E first, and then I do the probability of E and F second. I just like to do that. So let's do the probability of E, which is you select a non-blue token first. Okay, so the probability, this notation of B with a line above it just means not blue. So the probability that our first selection is not blue, and it doesn't matter what selected next, so really we could select green, blue, or red next, so we really just have to calculate the probability of not selecting a blue. Would be green and red are not blue. There's 34 out of 44. So we have 34 divided by 44. And let's leave it, we don't want to round within, so 17 over 22. Okay. Now we have to calculate the probability of E and F. So you select a non-blue first, and the second non-blue? The second token is non-blue. Okay, and the second is not blue. Okay, so remind yourself this is without replacement. So if the first one is not blue, that's going to be 34 over 44 times the second selection is not blue. So we already selected a token that's not blue, so now there's only 33. We've already selected a token, now there's only 43 left. So we have 34 over 44 times 33 over 43 is 51 over 86. Okay, now we can plug in. So this was just work we had to do. So we can plug in to find the probability that the second token is not blue, given that the first token is not blue. Okay, so we have 51 over 86 over 17 over 22. Do this, divided by that. Press enter, we get 33 over 43, which is about 0.767. Okay, so there you go. All right, and I can make another video with some more problems on it.